Hi everyone, sorry for the delay for this video. I got a bit caught up with some of the code, and you know how Christmas is, this, that and the other. Not to mention I've added a few extra features that I didn't originally intend. So the timescale was delayed by, what's it, the 29th today, 4 days, but that's not bad considering. Sorry about the glare, I'll get the camera to be sorted out in a second. Right, so let's just go over some of the hardware first. We've got a new type of EC meter, or should I say TDS meter. We've got the gravity, or the DF Robot Gravity TDS meter. I've used that just because it's a lot cheaper, still good accuracy. Got that. Got a generic pH sensor, just your average one for an Arduino. That costs literally £10. That costs £15, so that's a considerable saving compared to the old EC sensor I used to use. Let's grab it now. This thing here, that literally cost like, quite literally, I think it was £60 to £80. Yeah. Old technology these days. Got our 8-channel relay here. We're using 4 of the 8 for different things: water heater, a light, inlet pump, outlet pump. I literally can't remember the rest. A CO2 regulator, and there's something else in there I'm forgetting. I'll remember it in a second. We'll get around to that. We've got a DHT22 to get the air temperature and humidity. We've got our Dallas temperature sensor, DS18B20, I think it's called. That would normally be the waterproof version that I have in that tub down there, but you know, my table isn't that small, I've got no space in my house, so it's literally just living on my table. So exactly the same sensor, but just not with the long lead. We've got our waterproof ultrasonic sensor. That's dangling down by my headphones, down there. What else we got? Got our MOSFETs. You can have a dynamic amount, 4 to 6 of them, and they're controlling our doses. Parastatic pumps, whatever you want to call them. We've got our MCP4151. I don't know if I got that name correct. I've got a parts list I'll show at the end, but that's a 10K 257 step digital potentiometer used to calibrate the pH sensor. You would normally remove that 10K analog pot there, or what are you going to call it, that 10K screw pot on the pH sensor, and replace the wires directly to the digital potentiometer, allowing you to calibrate it from the graphical interface. What else? Display. Yeah, old Adafruit, very expensive display combo, being the display driver and display, you know, that costs about £80 for both of them. I've only used them because they're glued down from the old project. Let's cover that light up. And now I have got one, tested it, perfect fine. Bi display, R8875 800 x 480 display, 4-wire SPI, but you do need to solder on an extra pin for the interrupter there. There you've just got your SPI pins and your power and ground, or a couple of power and grounds. You need to use one of each. Yeah, this is far superior, only costs £35. It's even got an SD card that I don't utilise, because I find them tacky to use in long-term projects. By that I mean if this is ever going to be made into a commercial project, I see no need for an SD card. You'd actually use a flash chip. It's got a front chip on there for that matter. It has got a flash chip on there. Didn't have it on this one. Don't know. I thought I selected it, but they haven't put it on there. Whatever. But yeah, and you can even actually access the remaining memory on the main chip. You've got about 1 kilobyte of memory you can use in there. I don't really go into that much detail though. I haven't actually utilised it, but you can do it. The code's there in the display, the R8875 library. So yep, you can use either this really expensive combo, which no one really would, or you can use that one, which is auto calibrating as well, so you don't need to get all these stupid problems I get with this display where it doesn't know where its touch is at unless you manually calibrate it, and even then it's not mapped correctly. It never is. You know, like the very bottom will be out compared to the very top. Only the middle will really be correct, and it gets worse as you go up higher or lower. I'm going to turn off that LED in a second. The glare is amazing. Let's put a thumb over it. We've got the Arduino Nano here. That's running via I2C connected to the Arduino Mega, the Mega being the slave. The Mega being the master, sorry, the Nano being the slave. And this Nano's primary role is to control two zero cross detection modules. These are Robot Dylan AC light dimmer modules, but I don't know why they call it that. They're really limiting themselves, because even on their website they say that it can control heating elements, pumps, fans. My dogs just came down. Hey Murph. Say hello to everyone. You're a good boy. Yeah, so this is a zero cross detection module, and it can do up to 600 watts, and it can be used on inductive loads, heating elements, fans, pumps, you know, general lighting. Murphy, no. And I'll play with you in a minute, I promise. And anything else, you know, just your standard AC equipment. And here I have a fan connected up to it. You meant to have two of them. I've actually got a couple more over there. I've got the pin outs for the other ones, you know, these pins over here. But I only saw for this demo the need to plug in one, no need to drag down another rock fan. But it's also got the RGB LED and a speaker plugged into it. Oh, I unplugged the speaker. I remember that was annoying me earlier on. You can just disable it in the menu, but when I'm doing testing, I find it's just easy just to pull it out. So there's the active buzzer plug back in to the slave, covering the LED up. We can turn it off in the menu. We've also got our DS, is it a 3231? It is DS3231 RTC clock that we use for getting our dosing timing. Well, making, should I say, we use the RTC to ensure consistent dosing timing. That's much better. Am I missing anything? I suppose I should be the one saying, asking myself, shouldn't I? No, let's just say that's all the hardware done. Going on to the display. Oh yeah, I should say that. I killed my pH sensor. It didn't have its little liquid cap on when I had it in storage for basically a year. And the black platinum literally just flaked off the anodes. So my pH sensor is dead. Dead. But that doesn't matter. I know the code's perfectly sound. It's literally just an analog read of a pin, nothing more. So we'll leave it at that. The home page, as you can see, it's been adjusted. We've got a graph on there showing the sensor history at the graph interval. Your current target, in this case the fan speed, the actual fan speed, your min target, your max target, and the time. If there is an offset for a given sensor, it would show the offset. This is interactive. There we've got an offset there. Let's just go back one or two, whatever, you know, forwards again. Goddamn finger. This display is so scratched. I can see it all along there. You probably can't see it in the camera. Anyway, there's our home page. You've got all the sensors in there. Let's just go over to this. You've got your sensor pages, so your target range between your minimum and your maximum. So here we're asking it to maintain an EC of between 1.4 to 1.65 plus minus 2.5. You don't need to set the tolerance to anything really if you don't want to. It's just to allow for particle density in your tank. So by that I mean when you first pump in your nutrients, you're going to have what you could call hotspots where some nutrients is higher than others, and also your sensor will drift around a little bit, just generally anyway. So yeah, you've got your maximum tolerance. The same principle. Oh, I'll say it quickly. This EC page, you can go into settings and change it to parts per million. The icon will change up there, and all these values change to parts per million values. Not just a mapping, but their own values in themselves. Much better. You've got your pH page. Exactly the same kind of principle. Your min and your max target and your tolerance. That's for your pH. CO2. We don't need a minimum max, we've just got the minimum. So when it gets below the minimum, it's going to put it back up to it, whatever. But sorry, it does it at exact time. So you set the timing. So let's say at 10 in the evening, it will bring it up to 800. So I could actually just rename that to target ppm. It's not actually really a minimum, it's just what it's going to. Tolerance, so just playing with big numbers here, wouldn't really be that high, would it? Your room dimensions, it needs to know this because it works out the gassing amount exactly using a trusted scientific formula. So you set in your length, width and height of your room. Murphy, in a second, you've got your din-dins. You set your flow rate in litres a minute. I couldn't fit litres a minute in there. I suppose I could put the mins below. But no, and then you've got your interval. The time, like I said, that you want the gassing to happen. And whether or not you want to disable the fans whilst the gassing's happening and for X amount of time afterwards. So let's say you set that to whatever, 200 minutes. The fans would stay off, and that's from as soon as the gassing starts happening. You've got your water level page. So this page is your water page, your water temperature and your water level. Here, same principle. So if the water level gets below your minimum, it would then fill up the tank to the maximum amount, and it will dose some nutrients. You set the nutrients amount in the settings page. I'll show you that soon. So by that I mean when the tank's filled with fresh water, obviously it needs to pump in quite a significant amount of nutrients, so you actually tell it how much to start with as a baseline when it's refilled the tank. Again, your tolerance. You also got your water temperature, same kind of thing. Got your doser page. So this page is just for every X amount in your interval. So let's say every 4 hours it'd pump in a set amount of nutrients. Unless you've got machine learning turned on, then it would learn how much each milliliter adjusts the tank and then recalculate the amount. Not adjusting these values, but in the background these will remain as you set them, but if you have machine learning enabled, it would work out how much change each milliliter actually does and then adjust the dosing amount to the correct amount. You can have a dynamic amount from 1 to 6 doses. Here I've got it set to 6. You can change the modes. The first two are set in EC mode, fixed in EC mode, but these two, this can be, it goes alternating, so this can be EC or pH plus, as in pH up, or this can be EC and pH down. You can set, this is just the normal, this is the amount of milliliters they're going to dose. You can prime them. If I had one plugged in, you'd see it spin around if I press prime. And that literally just allows you to manually put in some nutrients, or, as you'd expect, prime the tube lines. Going along, because there is 6 of them. Just no point making this video really long. As I said, you can change their amounts as well. So I set that back to easy, whatever, pH, blah blah blah. Dosing amount, change all these up. Cool. Oh, that was the end of it, wasn't it? Lighting page. Light on, light off, mode. Set to on the relays. Let's I don't know which part to show. I'll just take my word for it. I'm going to press the off button. You're going to see this come off. Yeah, and put it back on. Yeah, cool. It's the lighting page, so that you can control up to 10 amps on one of those relays. So that's more than enough to put in a couple of 600s or a 1000 watt light. Got our fan page, dual AC fan control. You can either have a fixed fan speed, or you can tell them to control the temperature or humidity, or both. Only one mode for each fan. So let's say this fan 1 would be in temperature mode, being the extract fan, and fan 2 being the intake fan, we set to humidity mode. I'll adjust that a bit in the future, but for now it's working. Just making sure the AC's on. Got that on, and let's turn on the fans, eh? Oh, so I'm skipping stuff here. Got obviously your fan 2 page, your min and your max speed. Got your target air temperature, same kind of principles, your min, your max, your tolerance. Humidity, same kind of thing. So as I said, you've got modes. You can either have it on temperature mode or humidity mode. Same for the other one. They can both be the same. but that's the generic thing that everyone will do. Let's put it on a fixed speed for fan 1. That literally, oh, which way is it? Mate, I'm going to see now, it's this way. You can see it's already starting up because I've set to fixed speed and the maximum is set to 100, and when you set to fixed speed the minimum speed equals the maximum speed. So yeah, 100% fan speed, that means it's literally just going as fast as it can. If you hold down any increment button for a set amount of time, it will start adjusting in 10 times the value. So there we go, it's going up quite high and it's too low. Let's set it to about 30. Oh fine, that's a good speed for my fan. Now if you don't be silly, it's going pretty slowly. I mean, you can't really tell on the camera, but it is. And that's, again, every bit of code here is my own. None of it is copied from anywhere. And the code that Robot Dylan give you is called pulse skip modulation. And even then they wrote the code wrong, so it did it every half sine wave instead of every full sine wave. And your fan would just shake along the floor. If you're controlling a light, it'll probably be alright. But pulse skip modulation certainly isn't what you want to do. I'm using something called a sawtooth method. And it ensures that the timing between every single half wave is exactly the same. The code has to run on the nano extremely fast. It runs, as I said, in 4 microseconds each loop, and at the worst case scenario it will take 18 nanoseconds, but that's required because we need to get the 0 point time and then work out how long before we turn it on or off, whatever. So yeah, we can control 2 AC fans. I'm going to turn off that LED in a second, but we'll get to the settings page in a minute. Let's turn it, 30.4%, so leave it that, whatever. The actual ESP32 module will normally be set there. I don't have it plugged in at the moment because I want to rewrite the code. It used to be connected via serial, but that's just far too slow. I now use I2C, and I'm sending a lot more values, and I want to receive a whole different range of values, so I need to write a code that dynamically accepts a switch case and value and assigns it back to the mega, so you can control or adjust values from the web page. As you can imagine, I haven't started the X. That's quite a big thing to write all the server code and the web code and then the ESP code, and I'm not going to rush to that, I can tell you that much. But the Wi-Fi code will be there soon enough. Warning page, I've disabled most of the warnings just for this demo. You can do that in the settings. It'll just drive us nuts with it beeping away. That's why I had that buzzer disabled. But yellow for a minor warning, red for a major warning. You set your error margin. If the sensor reading is below your target and it's within the error margin, then it's not. Let's say you've got your target set to 100 and your error margin set to 50. Therefore, as long as your sensor is between 951 to 95. Oh mate, I can't be asked to do maths right now, but I'll say that again. If you have a target of 1000 and your error margin is set to 50, therefore between 950 to 1000 would be a minor warning, and anything below that would be a major warning. That wasn't hard, was it? I'm being a demo today, you know, as with demos. Presentations, whatever you want to call it. Yeah, you've got your warning page. I don't really need to cycle through all of them. But, ooh, ghost touch. Shitty display. Anyway, yeah, that's the warning page. What to go over to next? Got your graph page, got all your different graphs down here. Whatever, let's show you temperature. Damn it, I need to work on my fingers. I'm having to look through my camera, or look through my phone display to work out where my finger is, and it's rather difficult. But yeah, we've got our graphs there. Got your max mins, history. I need to just realign this a little bit, don't I? It could just be pushed over a little bit. They're all meant to be central aligning, like that. So I'll just sort that out. Not really a bug, but just a improvement. Me just playing with profile, so you can see I've loaded profile 1 because it's highlighted. If you haven't seen this before, this is where you save and load profiles. Nothing saves automatically. user profile wise, there's actually two different profiles. There's one for system and one for users. The system one will change every time you do a calibration. That's all that's really saved in there is calibration and profile names. So yeah, you can save all your settings here, literally everything, to a given profile. So you could you could call this vegetation and this one flowering, because you can rename everything. So let's just delete character. You can go into uppercase, but I'm just being lazy. I should really just. That's my name. And you actually get a bit of feedback now. Do you want to save the profile? Whatever. Yeah, I'll save it. So that's our profile page. And now into all these different settings. You can change the background colour if you really want to. Nice. It'll probably be hard to read everything on this page. I'll just put it back to blue. I love blue. Display timeout. That's been annoying us, so let's turn that off. Graph interval, how long it would take before the next before the next graph value is updated. Set the date time for RTC, temperature in F, height in inches, temperature in Fahrenheit, sorry, height in inches, EC to TDS, note that top icon. Now it's in parts million, and then if we went over to that page, it would say parts per million page. I could show you that in a minute. Oh, my back's killing me. Environment, like I said, number of doses, dosing interval, how long before the next dosing interval, or next time before we pump nutrients. Override interval, so if it's pumping the same thing, because it's worked on a percentage basis, let's say that the EC was out of range for 3 tries, and the pH was out of range, but it's on a percent basis, so if the EC was out of range by 50% and the pH was out of range by 30%, therefore it would be constantly just adjusting the EC, but when it gets to X amount of interval tries, 3, it would then say, alright, stop trying to just dose the EC and let's go back to the pH. Just therefore, so you're not constantly dosing the same thing, because in my testing in the past, I found if you didn't have that, and one thing was constantly out of range, it would never actually try and adjust the other, which is not what you want. You can disable the different things, so I could disable ppm dosing, disable pH dosing. I should say I could call that control. I'll rename that to control. So disable ppm control, and that does rename. So if that was in EC mode, that would say disable EC control. Disable pH control, disable fan 1, disable fan 2. This list is quite long, so I'll go for quickly. Disable height control, water height control, couldn't fit in there. Disable water temp control. Disable refill on dates. I'll show you that's enough. So you can tell the tank to refill and drain and refill on certain dates. You can tell it to refill when the tank gets low. Got that turned off because my water temperature sensor isn't in there. You can disable machine learning. I'll talk about machine learning in a minute. Autofill settings, just show you this. Where's my finger at? So this is the amount of nutrients it's going to pump in after refilling the tank. This is separate to that page. You'll probably set this to like 165, whatever, 60, and then whatever else the amount you want. Again, I've got 6 doses. Go over that. Note the slice icon. When you get to the end of your doses, you go into this page. Oh, I thought I fixed it. So when you slide, it thought I'd touched the page. There's meant to be a delay. Not a delay like you think, but meant to be a debounce time after sliding, but obviously not. Come on, camera, what are you doing? Camera! One sec, camera being gay. That's meant to say disable. I write that in a second. That was to say disable refill on dates, disable refill on low. Couldn't fit it in there, but I just need to push the text down, write disable above it. As I said, these are the dates that you can set to refill on. Whatever, set it to refill on the 20th of each month and the 13th. Didn't actually mean to press that one. The time that you want it to refill on. Yeah, exit. Got to try and get through this. My back's starting to hurt. Drain timeout. So this feature is quite important. If you're draining the tank and it is unable to drain any water any further, or pump in any water any further, so the sensor reading remains the same, and it hasn't reached the target, it would time out and just assume it's done its best. So that's good for, you know, if it can't drain that last bit of water, it won't just sit there forever trying, it would actually time out and say no. Or if you're refilling and you've got an overflow and it doesn't ever get to your target maximum amount, it would time out. Again, you can change that number. Got your dosing modes. Yeah. Oh, and that's the end of the page. System page. I recommend you don't play with any of the sensors except for the CO2 one, because if you disable, for instance, the water temperature sensor, that would then disable the EC and TDS readings and control, because EC and TDS readings are dependent on the water temperature. So in other words, I'd only ever disable the CO2 sensor, just don't touch the rest. Naturally you do have others down there, the other sensors. The air sensor is the DHT22, so that's that. Oh, you do have other stuff down there, don't you? You got your Wi-Fi, you can clear your Wi-Fi details. By that meaning, my old code would actually send or the new code would have it too. You can tell it to actually delete every piece of detail off the Wi-Fi chip, so you know, just for paranoid people really. Clear graph history, we all know what that means. Clear max mins, yeah. Clear machine learning. I thought there was one more down there. I thought it was meant to be a factory reset. Is it just display working out, or have I... Oh no, I just added that. I did the clear machine learning last night. I haven't updated the number. So this page is saying it's got like 10 values, but in the actual slider I said slide up to 9. So we're never going to get to N1, don't worry about that. But it would say reset device to factory reset. So that would delete every single setting and put it back to default, like every profile, everything. So yeah, don't do it unless you want to. As I said earlier on, I disabled some of the warnings. Probably want to hear one, don't you? How annoying. Leave that as it is. It will tell you what one's out, just so you actually know what to disable. We don't need to go for the whole list, it's just a list of all the things to disable. And yeah, you can calibrate your stuff, as I said. So calculate height is getting the empty water tank depth. It needs to know the empty tank depth to get a correlation of the water height. So if you know the empty tank depth and the current water height, you can then extrapolate the actual amount of water. When we could, I can't remember here, there we go. Please make sure the tank is completely empty and the sensor is correctly mounted before continuing. Don't want to do that. Calibrate ppm. Yeah. Calibrate CO2. It's funny that they still use 400 parts per million global warming. Don't think we'll achieve that these days. You have to do a fixed environment and actually put in pure oxygen rather than pumping in CO2, wouldn't you? Or nitrogen. Well, no, nitrogen would interfere a bit, because as far as I'm aware, these sensors don't actually differentiate between gases that well. Calibrate pH. That works on an ohms basis because it's a digital potentiometer. Yeah. Oh, that was meant to go up in increments of 10k divided by 257, which is like 67 or 87 ohms, can't remember. And calibrate doses. And that would be it, won't it? Except for me discussing the machine learning. Calibrate doses is their speed. Ooh. I forgot to put the arrow in this page. It's meant to have a little sliding arrow. But I'll put that in. That'll be done tonight. So that's it. And yeah, machine learning, as I said, basically all it does is records the history. So when you first turn the device, even if you have machine learning enabled, it will, for the first time, use the amount you have set in this page. In this case, that amount. And then it would work out the change that it's actually made on the next dosing interval. So if you've got it set to dose every 6 hours, it will take the reading on the first dosing, and on the next dosing it will compare the current sensors to the previous saved readings, and then work out how much the values actually changed in comparison to the amount of nutrients and a few other factors, quite a few other factors, and then it will come up with a value of how much each milliliter adjusts the tank. That's then placed into an array, up to 20 values for each sensor, and then it can actually get a bang on average from that array as to how much each milliliter actually does adjust it. So then you get an exact average of its dosing potential, and then it would adjust the milliliters to that amount using a multiplier. So yeah, it has got machine learning. It would learn over time. It would take up to 20 doses to learn it's to be at maximum precision, and then once it's got those 20 saved values, it would then push back the array and get the latest 20. It's always got the latest 20 values, should I say. Yeah, so it's got its machine learning in there. So we've got TDS control being EC parts per million, we've got pH control, CO2 control, water level control, water temperature control, we've got 4 to 6 peristaltic pumps or doses, we've got external lighting control, we've got dual AC fan control to control air temperature and humidity. Wi-Fi will be added soon enough. You've got your device warnings, you've got your home page. Go back to that. Yeah, pretty consistent value, as I'd expect. Got your graph page, which is your sensor history. Got your maximum page. Got your profile page to save and load profiles. And we've got our settings page. And if you just hold on a second, move back, I'll just show you what you can expect. Again, I'm looking through my phone, so I actually need to see where everything is. Murphy, don't cry. My doggy wants some attention. So we've got diagrams in there. Obviously you've got the code. And we've got even examples in there. So I've even written examples using the correct pins for you to test the sensors, test the RTC, test the display. Whoa, what's my camera going with? Test the digital potentiometer, test the EC and TDS, including the transistor circuit to isolate each sensor. You can test the relays, test the doses, and then test the I2C to control the fans, the alarm, and the buzzer. What else? Got diagrams in there. Some of them are basic, some of them are advanced. So you've got how to wire up the temperature sensor, a diagram with the entire project. Note in mind that the power lines are incorrect. By that I mean it's all assuming that they're all connected to the same power, because I just was a bit OZ and didn't want to have every wire connected. In reality, you need to make sure that each circuit or node to Pacific has enough power. I recommend 2 amp regulator. I recommend a 2 amp regulator for the relays, because you're going to use 6 of them, they're juicy. 2 amps for the doses, again you can have up to 6 of them. 1 amp for the sensors, and another 2 amps to control the Arduino Mega and the Nano. Note in mind that the Mega is actually powering the RTC, the display, the DHT22, the Dallas temperature sensor, the ultrasonic sensor, and the digital potentiometer. So yeah, 3 2 amp regulators and 1 amp regulator. It is a juicy project, but what do you expect? Again, I'm a coder, not an electrical engineer, so those values may be wildly wrong. You've got how to wire up a potentiometer there, how to make a MOSFET simplified for people who just want to see an illustration rather than a wire diagram. The total schema, again the power lines are a bit wrong. I did use Fritz, so I'm not gonna lie. I've got AutoCAD and stuff, but it just takes forever. Again, forever, and they're probably not even accurate because I'm not an electrical engineer. I'm just showing you what wires that need to be connected. You've got your transistor circuit here, so this is how you isolate the sensors. Again, I've spoke to people about that. I spoke to electrical engineers at work. They say it's perfectly fine. The only problem you'll get is the voltage drop. It's in reality there isn't 5-volt output. It's actually a the input. Sorry, it's actually 4.7. No, 4.3. But my teacher said that it actually got 4.42 volts. But in my code, you just adjust the AREF, the analog reference, to the amount that you're actually getting across that for the EC and pH in their readings, whatever. And then for people who just want to see an easy way to do the transistor circuit, that's how you do it. If you want to use optocouplers or something else to do it, the principle here is the pH sensor and the TDS sensor basically have to be floating. By that I mean you're essentially trying to cut the power and the ground at the same time. Now, these transistor circuits aren't doing that, but the impedance or the resistance is so high that it might as well be when we're turning off base transistors. So effectively, they're kind of practically floating. So in that sense, even though the sensor is still in the same pot, like in immediate proximity, it's absolutely not connected, because if the ground or the power is connected to either one of those two sensors and they're in close proximity, the voltage reading in the water would be affected, because it will either travel down the ground or be supplied additional power. So the principle is the pH and the TDS sensor have to be completely isolated from each other whilst the other one's being read. And that means literally trying to cut the power in the ground. And that's how I do it. If you want to use optocouplers or something else, fine. But the principle is you either want them to be floating. So if you're reading the TDS, you want the pH sensors, power and ground to be floating. And that sounds odd, but they worked on water ionization and resistance. So if you have a ground or a power plugged into that water whilst another sensor is trying to read, it's going to affect it. So yeah, make sure that's done. Again, I've provided you that and the code's there for it. Initial testing, you don't have to use the transistor circuit, but make sure they're not in the same pot. And then once you've got the sensors working, add in the transistor circuit. Spent so much time writing on this for you. Literally over Christmas. So you got your bill of materials. Whilst I last time just put the name down, people were coming back to me saying they found different search results for different things. So I've even put you in a little fancy picture for each one. And you've got all your stuff there, even down to the bit of perspex that I'm using to mount it all. So I don't expect anybody to say to me, what stuff do I need? Where you get it from doesn't matter, just make sure it's just the right one. The doses can be 5 to 12 volts. I'm using those ones there. They're in my drawer behind me. So that's your bill of materials, or your parts list, whatever you want to call it. And then look at that. I've even written a bloody, I shouldn't swear, but it's not really swearing. Only my mother would say it's swearing. Hydro master wiring and testing. So yeah, to wire up the display, I've told you what pins. I've even told you to calibrate if you need to. And run some demo code. Again, all the pins are already set in the demo code. How to do your RTC, how to do your relay, how to do the MOSFETs, or the peristaltic pumps. It's just a MOSFET circuit, so it doesn't really matter what's connected to it. How to do the pH and TDS sensor. How to do all the other sensors, because the pH and TDS are the only ones that are finical. How to do the digital potentiometer. And how to do the I2C communication to the nano. And again, I'll make extra emphasis on the fact that you're playing with AC. If you don't have any understanding of the dangers of AC and how to wire it correctly, even if you do, if you're not certified, get a certified person to do it. I don't want to hear if you did it yourself, because I take no responsibility for it. So yeah, if you're playing with AC, get a trained professional to do it. In reality, you're probably not going to, but I've got to say it for obvious reasons. And I don't take any joy if anyone does say to me, oh, I did it myself. You just don't tell me that. As far as I'm concerned, you've got a trained professional to do the AC wiring for yourself. Yeah. Alright, so you've got all that lovely stuff in there. And then the code. One for the nano, one for the main control for the Mega. Yeah, that literally took me a month, man. A month. I don't mean to sound naive, but if you want to give me any donations, that'd be amazing. I put up a donation tab last year, maybe a little bit over, and I've quite literally received 4 or 5 donations in all that time, and I get so many people asking for help and this, that and the other. We all know how little time there is in the world, so I've saved you a million years writing this all for you. If you can just give a small donation, I'd be more than grateful. And not to sound naive, if you do give a donation, I don't know how to say this properly, I'll be happy to assist you with some information or whatever, but I'm not going to sit there and write a week's worth of code for a £20 donation. So if you want me to do something, do ask. I am quite tempted to have 2 different versions. I don't see why it should be a problem, but would it be unfair to let me know your thoughts on this? Would it be unfair to give the binary code for free and then give the raw code to people who actually pay for it? How much do you ask? Well, let's say £20 to each person who wants it, the raw code, and anyone that wants it for free can get the binary files. Therefore they can still use the product, they just can't modify the code. Because I love open source. All my other projects have been free, but this one has took forever and it cost a lot to buy all the parts, a lot of time. But I don't want to upset people when I have next to no money. My PC is in my kitchen. I think that says it all, doesn't it? My house is from here to here. So yeah, I know what it's like not to have any money, so I can't be mean and say you have to pay for the code. But then at the same time, if I give it to you for free, but it's the code that can't be modified, is that really a problem? Oh, ethics. I don't know. Yeah, but that's my project. And I hope you all enjoy it and let me know how it works for you. I will be constantly keeping it up to date, and if anyone finds any bugs, they will be more than likely fixed the same day. Yeah, please follow me on YouTube. Not that I really care about that stuff. And yeah, cheers for watching. Bye.